space telescope James Webb has essentially provided the clearest image of Proxima ever captured, providing remarkable insights into a potentially habitable exoplanet. This discovery beckons us on a thrilling journey, traversing space to solve the mysteries of Proxima B and determine if it could be the next Earth, a place we might one day travel to in the vast Proxima cosmos. Proxima B resides in its star's habitable zone, Proxima Centauri. However, this planet is not like any other. Proxima B is only 4.2 light-years away from us and is obscured by mystery and wonder. Could it be another Earth, complete with oceans and thriving life? But wait, there's more. Proxima Centauri isn't the only planet in the system. It also has a companion, Proxima Centauri C, and there may be additional unsolved cases within this system we haven't yet uncovered. Proxima Centauri is remarkable in that it generates roughly the same amount of energy from its star as Earth does from the Sun. Does the Sun actually permit this? This could indicate that water is on its surface, perhaps even life. As we venture beyond our solar system, we come across a completely new realm of exoplanets, planets orbiting stars other than our Sun. With over 20,000 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even roam freely through space, unbound to any star, like cosmic wanderers. Among them, Proxima Centauri B stands out as a particularly fascinating and alluring planet. With a year that lasts only 112 Earth days, and a distance from its star that places it closer than Earth is to the Sun, one side of the planet is constantly illuminated while the other side remains in perpetual darkness. Let's get a closer look. Proxima Centauri, the star around which Proxima B orbits, is part of the Alpha Centauri triple star system, which includes Alpha Centauri A and Alpha Centauri B. These two stars combine to form a binary system known as the Alpha Centauri AB, and are the third brightest stars in the night sky, with light just under 2.7 times that of our Sun. Proxima Centauri, also called Alpha Centauri C, is a red dwarf star located 0.21 light-years away from the other two stars. It is the star closest to Earth, and the term Proxima means closest in Latin. Discovered by Scottish astronomer Robert Innes in 1915, Proxima Centauri is not visible to the naked eye due to its faint appearance, with a magnitude of 11.13, much dimmer than the human eye's limit of 6.5. Despite being our closest celestial neighbor, Proxima Centauri is still an intriguing star to study. Red dwarfs like it are highly efficient in energy production, not generating a lot of energy, but preserving brightness for trillions of years due to internal convection processes. Proxima Centauri will remain a main sequence star for an additional 4 trillion years. But the habitability of red dwarf systems like Proxima Centauri is still debated. For instance, it is a flare star, meaning it experiences frequent and intense radiation bursts. In addition, because of its low mass, its habitable zone is much closer to the star, estimated to range from 0.023 to 0.054 Australian dollars. Yet, Proxima B's habitability is questionable. It is frequently bombarded by intense ultraviolet light, much stronger than what we experience from our Sun. This radiation is so harsh that even light hydrogen particles, along with nitrogen and oxygen, are stripped away. But that's not all. Just because a planet resides within the habitable zone of its star doesn't necessarily mean it can support life. Proxima B may not even maintain a steady atmosphere, which is crucial for regulating temperature and maintaining a water-friendly surface. Without it, any potential life would be vulnerable to extreme space weather, making the planet inhospitable. Although Proxima B may appear Earth-like at first glance, it is far from being suitable for life. Scientists remain cautious, recognizing many factors that could make the planet uninhabitable. The search to uncover the truth about Proxima B is still ongoing, and some scientists remain hopeful. One tool that has captured the attention of astronomers is the James Webb Space Telescope. After years of anticipation, the telescope was launched in 2018 and is helping us determine if life could exist on Proxima B. However, as with all scientific endeavors, there are difficulties to consider. Numerous adjustments were necessary to ensure the James Webb Telescope delivers precise images. As astrophysicist Abby Tabor from Harvard explains, if a planet like Proxima B can absorb light from its star, it can also emit it as infrared radiation. The James Webb Space Telescope was specifically made to detect this, allowing it to capture infrared light images of the planet's surface and search for patterns that might indicate water or an atmosphere. But what if the planet has an atmosphere that isn't conducive to life? The presence of an atmosphere doesn't guarantee habitability. Ed Turner, an astrophysicist from Princeton University, cautions that Proxima Centauri B might have an atmosphere as dense as Venus, which would result in surface temperatures too extreme for life. The search for Proxima B's mysteries is filled with obstacles. In addition to the promise offered by the James Webb Space Telescope, there are also financial and technical challenges. With mounting costs, space scientists feel the pressure to discover ways to observe planets like Proxima B more effectively. But the potential rewards are immense. The chance to discover unknown worlds and the secrets of distant planets that might harbor life is a worthwhile pursuit. If Proxima B were indeed habitable, could we one day visit it? Its status as the closest known exoplanet to Earth makes it especially intriguing, very much like exploring our own backyard. What makes it even more compelling is that Proxima B is practically the same size as Earth and lies in the habitable zone of its star, suggesting it could have conditions favorable for life. Its proximity to Earth makes it an ideal goal in the search for life beyond our solar system. Though we cannot reach Proxima B just yet, it is certainly on the radar for future missions. As technology advances, exploring this Earth-like planet might one day be within reach. However, such a journey would face formidable obstacles. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, an innovative solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, including Proxima Centauri. This technology harnesses solar pressure to maintain the spacecraft's course, eliminating the issue of fuel depletion. Even more fascinating is the fact that this cutting-edge technology could provide useful information about the potential for life on other planets like Proxima B. However, as with any ambitious endeavor, there are limitations. The presence of an atmosphere does not automatically imply the presence of life. Proxima B could end up resembling Venus, with its thick and hostile atmosphere. Besides, even if Proxima B had conditions similar to Earth's in its early history, the constant radiation from its parent star may have long since stripped away any protective magnetic field or atmosphere. Without these crucial elements, the odds of life thriving, or even surviving, become increasingly slim. Still, the allure of discovering another Earth drives scientists and visionaries forward. If Proxima B is proven to be habitable, it would revolutionize our understanding of life in the universe and potentially mark the beginning of interstellar exploration. Such a breakthrough would shift the question from "Are we alone?" to "How soon can we go?" To that end, numerous missions are being proposed. Among the most ambitious is Breakthrough Starshot, a project backed by physicist Stephen Hawking and entrepreneur Yuri Milner, which aims to send a fleet of light-powered nanocrafts to the Alpha Centauri system. These spacecraft, traveling at up to 20% the speed of light, could reach Proxima B in just over 20 years, a monumental leap from the 75,000 years it would take traditional spacecraft. However, this mission is still in the planning stages, and many technical challenges remain. How to protect the craft from interstellar dust at such speeds, how to decelerate once it arrives, and how to send meaningful data back to Earth. But even with these obstacles, it represents a bold vision for what humanity might accomplish in the near future. At the same time, ground and space-based observatories continue to collect data. The James Webb Space Telescope, Extremely Large Telescope, ELT, and other instruments may soon provide atmospheric readings, climate models, and surface composition analyses of Proxima B and other nearby exoplanets. Each new discovery adds a puzzle piece to the grand cosmic mystery. Despite the setbacks and the unknowns, one thing remains certain: the discovery of Proxima B has reignited humanity's dream of reaching the stars. Whether it harbors life or not, it has already transformed our sense of place in the universe. It stands as a beacon of what could be, an invitation to explore, to learn, and to hope. Perhaps someday, not in decades but in centuries, human eyes will gaze upon the sky of Proxima B, watching the red glow of its sun as it rises over alien mountains. Perhaps one day, children will grow up not under Earth's blue sky, but under a twin sunrise on a world that was once just a distant point of light. Until then, we continue to look up, fueled by the knowledge that the universe is vast, and we've only just begun to explore its wonders. The James Webb Space Telescope can detect emissions in the infrared spectrum, even if they reach only 5% of the daytime side's brightness on Proxima B. While 5% may seem small compared to other numbers, it's significant when dealing with a star much brighter than ours. If Proxima were our sun, this would be very important. Advanced civilizations on Proxima B may even use bright orbital mirrors to reflect sunlight from the daytime to the nighttime side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in a variety of sizes. Some are enormous gas giants, while others are similar to our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are similar in composition to Saturn and Jupiter, but are much larger. Some of these behemoths are known as super Jupiters, surpassing even the largest planet in our solar system. But there's more. There are also hot Jupiters, gas giants that orbit very close to their host stars. They exist in scorching worlds with temperatures high enough to melt metal. Imagine taking a close look at such a planet, with its furious storms and extreme heat. In addition to gas giants, there are Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and orbit closer to their stars. Unlike their gas giant cousins, these planets are often shrouded in mystery, with atmospheres that are difficult to study from afar. Not to be overlooked are the earthy exoplanets, which resemble our own Earth. These come in many sizes, ranging from smaller than Earth to twice as large. Some are classified as super-Earths, with masses more than twice that of our planet, though they are lighter than Neptune. One of the most enticing exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth with an estimated mass 7 times that of Earth. Although it's close to its host star, it's still within the habitable zone. Proxima Centauri b isn't alone. It has a companion, Proxima Centauri c, which orbits much farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 through pre-recovery of Hubble data. Even more fascinating is that Proxima Centauri appears to be an incredibly bright world, possibly due to the presence of a ring system. There is still much to learn about the Proxima Centauri system. In 2019, astronomers observed a change in the star's orbit speed, which could be the outcome of yet another planetary companion. If confirmed, this planet would be called Proxima Centauri d and would be roughly the size of Mercury or Mars. Imagine a life where the night sky is filled with stars, and numerous additional planets, each with its own unique characteristics. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an exact number of known exoplanets, we do know they're real, just like the stars that light up the universe. However, studying them comes with challenges. Exoplanets are often hidden by the glare of their host stars, making them difficult to observe. Thanks to technological advancements, direct imaging of exoplanets is now possible. To be directly imaged, an exoplanet must be big enough to be seen by a telescope, far enough from its host star to avoid being obscured, young and hot enough to be visible from Earth. These requirements limit how many can be imaged directly, but they offer a glimpse into the characteristics and components of these distant worlds. Exoplanets are most commonly discovered through the changes they induce in their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, which we can detect via radial velocity. Astronomers using the Kepler Space Telescope applied the transit method, which measures the dimming of a star's light as an exoplanet passes in front of it. This method has revealed valuable data on exoplanet size, distance, and temperature. Here are a couple of fun facts. Over 22% of Sun-like stars have Earth-sized planets in their habitable zones. The TRAPPIST-1 system contains 7 rocky exoplanets, some with water on their surfaces. Natural elements such as satellites or exomoons can also exist in other systems. With more than 4,000 exoplanets discovered, we know they are abundant. Hot Jupiters, due to their mass and rapid rotation, are the easiest to find, but many more exoplanets await discovery. NASA's James Webb Space Telescope is unveiling the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering data and capturing stunning images, revealing previously unknown wonders. Recently, it made a groundbreaking discovery: the first conclusive proof of carbon dioxide in the atmosphere of an exoplanet. This gas giant planet orbits a Sun-like star 700 light-years away. The finding is a major step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that the discovery would provide a new perspective on the universe, sparking global excitement among scientists. But that's not all. The James Webb Space Telescope has also been capturing breathtaking images and gathering infrared data. One notable example is the young object known as IRAS 110104105. The cool material of its wispy cloud is illuminated, while orange spots behind it reveal distant stars obscured by icy clouds. This research is part of Webb's Ice Age project, which aims to examine ice formation from its early creation to the development of icy comets. Additionally, Webb has imaged the inner workings of a dusty disk surrounding a nearby red dwarf star, capturing it for the first time at these infrared frequencies.